Well, we'll talk about humble and the other word hubris very soon. But hubris is excessive pride. Except, yeah, pride. Why do you get it so fast? Oh my gosh, you guys have a vocabulary. All right, it says here, write down the first, right? Okay. All right, so help me out with this one. It says, write down the first 5 terms of the sequence of the following definition. So, unfortunately, when I copied and pasted, it doesn't. Oh my gosh, que finito. Let me erase that. Let me make it a little bit thicker. No, what's wrong? Oh, I know why. Because yeah. This is almost acceptable. Use of 1 is 5. So how do you figure out use of R plus 1 using that definition? So use of R, use of 1 is 5. So what would be the first R you would use? You would use 1. You don't start at 0 here, right? And then you would put, is it okay I just write use of 2 equals to 3 times 5 plus 1? And that's going to be 15 plus 1, which is 16. Oh my gosh. Which is 16.
Yeah, because since the R is 1 is U of R.
Yeah, it's just plug it in. But what you realize now is that the next one, and this is, I guess, the important part.
Did you plug in 16?
16 times 3 plus 1.
Yeah, and then you just keep plugging. That's the dollar dot. The rest of that's confusing.
Well, which part is confusing? Oh, you understand this?
Yeah, after that.
Okay, so let's try and focus today. I'll try my best to be as explicit as I can be. And if you engage with me, it helps even more. And then I'm pretending to be a teacher and you're pretending to be a student and it works out.
What a great relationship.
There. All right, so let's get up. What's the next one going to be? When R equals to 2, use of 3 equals to 3 times use of what? Use of 2, which is 16, plus 1. So that's 48 plus 1, which is 49. So basically, if you were to do the sequence, I wouldn't require any more work from you. Maybe just once you see it, it's going to be 5, 16, 49. Then the next one, how would you do the next one? It'd be 49 times 3 plus 1. 49 times 3 plus 1, which is 148. And then the next one will be 148 times 3 plus 1, 445. And you just did the question correctly. You got full points. So easy, right? All right. So now the next two are not fun because it says suggest an inductive definition which produces the following sequences. So use of 1, the first term is what? 2. Now, the way you're going to say is to say use of R plus 1. And you ask yourself, okay, to get 6, I multiply by 3. To get 18, I multiply by 3. 6, right? So you would say, well, it's just 3 and whatever R it is now, use of R. And that's it. You're done. Don't overthink this. That's it. You're done. That's the inductive definition. Now, I'm thinking that this here means x to the third. This here means 5x to the second. This here means 25x. Yes, but when I copy and paste it, it just changed. Huh? It should be raised to the third power because a subscript is not going to work out with this. All right, so let's go. What's the first term? Use of 1. And I wrote mu there. Let me u. Equals x to the third. Now, use of R plus 1 equals to, well, let's see what's happening. What's happening is we're dividing by x. Do you see that? And not only x, we're multiplying by 5. So look, notice that here there's 1 times 5 is 5. 5 divided by x will cause, I just spit on my tablet. If I divide by x, instead of x to the third, I end up with x to the second. If I do it again with 5x squared, 5 times 5 is 25, x to the second divided by x is x. So I would say that it's supposed to be, oh no. No. Okay. I'm supposed to say 5 over x times use of r. And you're done. That'll work. Now, clearly, go ahead. Okay, so I have to be clever.
Did your homework at home?
She doesn't have colored pencils at home.
Why are they arguing about that?
About her homework. I guess her homework required coloring. I have colored pencils. I have a whole box of colored pencils that are mine.
Yeah, we
Color.
remember we used to do that last year. We used to color.
All right. So here's how this works. Look, what number would you look? This is x to the third. This is 5, and this is 25. Obviously, you're multiplying by 5. But at the same time, the x to the third became x to the second. How does x to the third become x to the second? You would have to divide it by x. And then x to the second becomes x. You would have to divide x to the second by x. So it looks like I'm doing two things. I'm multiplying by 5 and dividing by x. So 5 divided by x times use of r will take care of that. Because I'm taking, if you take x to the third and multiply it times 5 divided by x, you get 5x squared. If you take 5x squared and multiply by 5 divided by x, you get 25x. That's all. You're trying to recognize a pattern, trying to figure out how that happened. Yes, be careful. Okay, the next one. So, Natalia, are you good with?
Yes.
So far, so good. Okay, and the next one is going to be super easy, right? All right, so let's do the next two. Let me go to Chavez is here. Jonathan, Talia, Liani, she's here. Yeah. Alexa, Darian, Josue. Natalia went to veterinary. Johan, Miss Crespo's here. Adriana, Catherine, Shabeli, she's here. Samantha, Rachel, Lauren, Nicole, Catherine and Victoria, and Meliani. We're good. All right. So if you were to do this without a calculator, what you would have is you have 11 factorial divided by 9 factorial. Well, that's 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which equals 11 times 10, which is 110. And the reason it does is because all these cancel out. Good, 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 good. Make sense? Okay. Let's do the next one. Let me zoom in a little bit more on my paper. I keep on. Oh no. Is it back? I gotta be careful when I use these things. There was a way for me to keep it in place and be great. All right, let's do the next one. 8 factorial. I want to do it in red. 8. 8 factorial divided by 5 factorial times 2 factorial. I believe that's how it's going to look. So how do we do this? Well, you just 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 5 times 4 times 3 times 2 times 1 times 2 times 1. This cancels, 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 this cancels. 8 times 7 times 6 divided by 2 times 1 which is 8 times 7 times 3. Well, that's 56 times 3. What's 56 times 3?
Okay, wait, why did you?
Well, what's 6 divided by 2? You see that? I'm just being slick. It doesn't matter.
Oh, wait, I got the same thing. And I did it too.
So you did something similar.
I did, wait, you got 168.
Yes.
I did 8 times 7 times 6. I got 336 divided by 2. I got-
Yeah, it's fine. It's the same
Oh,
thing.
okay, but
So
that's what I said.
you're good. You're good. You're good. Don't worry. Are we good? All right. I'm gonna skip the inductive definition of Pascal because I haven't memorized it, but I'll come back to it so I can open up the book and just write it out for you. I want to go ahead and do things that are more important. All right, Pascal is important, and I'll do it. It's 4 minus r over n, whatever. It's just an inductive definition for it. It's not interesting. Now, do you want to try and do these before I do it? And I'll pause this, or do you want to do me just to do it?
Do one and then the other one.
The thing is that they're all different.
For which one? But the last two, I feel like you do.
Okay, so all right, fair enough. So let me do this one, and then maybe you should be in a position to do this one. All right, so let's do that. You did these?
I attempted.
Okay, so let's start with number 7, or I guess it's number 7. It says here, in the following arithmetic progression, the first 3 terms and the last 3 terms are given. Find the number of terms. So this is A's of 1. This is A's of 2. This is A's of 3. And this is A's of n. We don't know which n it is, but let's just say this is the last one. And they want us, oh no. And they want us to find n. How many terms we have there? Ladies, you're too loud. You're too loud. It's distracting me. It just seems like you guys are not talking about math today. All right, so the first thing I would do is I would write down my first term, which is A. And then I realize it tells me this is an arithmetic progression or sequence. And so I got to figure out my common difference. So what's my common difference here? 2 minus 8, subtracting 6, correct. So we're going to write -6. So here's what I do. There's 2 formulas that I have. There's one that says A's of, gotta make everything bigger. One that says A's of n equals 2 A's of 1 plus n minus 1 times d. This is to determine, this one here is to determine a particular term in an arithmetic progression. The other one we have is for the sum of an arithmetic progression. We call a series. This takes care of adding up all the numbers, what they would be, depending on where you want to end the sequence at. So this one's half n times twice the first term plus n minus 1 times d. If you do this algebra here, you plug into this equation, you get the sum of the series. Which one do you think we're going to use in this question? Do we use the first one or the second one? Is this a series or is it a progression that we're working with? Well, a series means that I am adding them all up. A sequence just means, hey, I know the first one, I know the second one. Can I get the third one? Can I get the fourth one? Do I know the fifth one? Like that. Yeah, you would use the top one because we want to figure out, what term is this guy? What n it is? All right. So what is the term? The term is -202. The first term is 8, right? I'm using this formula here. I don't know. I don't know what n I'm at, but I hope that when I'm done solving this equation, solving for n, that I'm going to arrive at, bless you, I'm going to arrive at the number of terms, because we know that if I put in -4 in this and solve for n, it'll give me 3. But we already knew -4 is the third term, right? If I put -4 in here and I solve for n, I would get, and let me try to solve it. I subtract that, that's -12. This is -6n plus 6. And when you subtract the 6 over, you get -18 equals to -6n. And when you divide both sides, you get n equals to 3. You see, it works. Of course, because it's a third term. What we want to figure out is what term is -202. So we solve for it. And you guys have the skill for that. You do have the skill for that. And so I guess I'll erase this example I put here. No need for it. But the first thing I would do there, I'll subtract 8. I'll end up with -210 here equals to 6n plus 6, I believe. And then when I subtract the 6 over, it's -216 equals -6n. And when I divide both sides by -6n, I get something. It should be a whole number. If you're getting a decimal here, you did something wrong. I get 36. So therefore, this is the 36th term. It's the 36th term in that sequence. And that's all there is to it. That's all there is to it. Make sense?
Yeah.
This is much easier than differentiation. In my opinion, it's super easy as long as you know the formulas and you know how to use it. Are you okay with that?
Yeah, I said it's very easy, but I got it.
Okay. Do you want me to zoom in a little bit more for the next one? Or you could also, you want to sit in my seat? Oh, okay. All right. Yeah, I'm pretty sure that the test I'm going to give you next class is going to be very similar to this. Yeah.
Can you give us the formulas for it?
Yeah, I'll write them on the board.
Okay, can you write in the note like this is the series?
Well, S will be the sum and series will be the one with just A.
Oh, you're smart.
You kept this.
As long as you can do this.
Well, I'm not that skinny. Am I skinny?
Yeah.
But I,
No, you can't like say that's like.
yeah, I'm not that skinny, right? I'm
thin.
No, that seems worse. You're big. You're normal. You're normal. You're tall.
normal.
You're like average. Average.
What do you mean by average? All right. Yeah. Wait till I put an inch on my arms. You'll see. I'm trying my best, but I gotta eat more. An inch.
Do you imagine it? Like, do you have like the
this
the one like 8 like
right. So right now I have 15s. So I gotta get it to 16 or 17, but that's gonna take forever. And then over here, this is the most best one I have. I have a 32 here, umbilical. So I got maybe an inch more of fat left. That's it. Maybe a little bit more. I can get it down to like 31 or 30. Oh, that's gonna be amazing. I haven't been that way in forever. So yeah, that'd be great. That'd be great. I mean, that's awesome. What can I say? But the thing is, how to gain the I'm just older. Whatever, doesn't matter. All right. Find the sum of the given number of terms of the following arithmetic series. Okay, so we got, how many terms do we have? 40. So which formula are we going to use? Are we going to use the one with the S or the one with the A? Yes. So what's my first term here? What's A's of 1? A. And now what's my common difference? So what's What's 5a minus a?
4.
4a, correct. And now you have everything, almost everything. What's n supposed to be here, by the way? Yes, 40. So now super simple. S of n equals half of n times twice the first term plus n minus 1 times the common difference.
Can we do an over 2?
Yes, of course. N over 2 is fine with me. So she just means this. It's the same thing.
Yeah.
So S of 40 equals 40 divided by 2 times twice a plus 40 minus 1, which is 39, times 4a. So that means S of 40 equals 20 times twice a plus, what's 39 times 4a? Well, we're at 39 times 4, 156a. And now it's going to be 156a plus 2a. That's 158a. And now you multiply that times 20. So S of 40 must equal, well, 3,120a. Oh, wait, I messed up. Yeah, well, 3,160a. And you're done. That's all there is to it. Yeah, that's it. No, there's nothing you can do. A, pick any number for A, and you write this out. You pick 2 for A. It'd be 2, 10, 18. Well, the sum of that, the sum for 40 terms, that's 3,160 times 2 for 40 terms. All right, so now that we have this, how about you guys give a shot to see if you could do the next 2 on your own? So, oh yeah, you want me to do this? And you were there? Okay. So here's what I'm gonna do. Let me go ahead and just pause this.